First and foremost, we want to thank We Build Denmark for giving us the opportunity to be part of this project. Hi, we're group B11, consisting of Sandra, Christian, and Sigurd. Yeah, and our starting point in this project has been the UN Sustainable Development Goals, where we have picked four, which are the most important for our project. And we have number 9, industry, innovation, and infrastructure, and then number 11, sustainable cities and communities, and number 12, responsible consumption and production, and number 13, climate action. And common for all these are that we'll have to look all the way from how the materials are produced and how they are moved from one place to another, the infrastructure, and then we have to look at how the carbon footprint of these materials are, and if it's something that helps the overall climate situation. And then we have looked a bit on building materials, where we have compared normal materials to sustainable materials. And when you look at a normal house in Denmark, you often see a foundation of concrete, and then upon that is brick walls and a brick roof, and the insulating material is often the rock wool or mineral wool. And all these materials are not the most sustainable, and they all require a lot of energy to produce, so that leaves a big carbon footprint. But when you look at the sustainable materials, we have something as wood, straw, grass, and cork, which is all something you can find in nature, and it's easy to reproduce these materials. And to name an example, you can look at cross-laminated timber, which is a really good substitute for steel in many cases. It's both easier to work with because the weight is less, and of course it's more eco-friendly. And yeah, we'll hopefully see a lot more of these materials in the future used in houses. And when you look at grass, that's the one material that we have worked a lot with, because we're using grass as an insulating material. Yeah, and that is much more sustainable because it's nature-based, and yeah. And then we will tell you a bit about our construction, and our construction is wood construction. And if we start from the outside, we have super wood, which have a lifespan of minimum 50 years if it's maintained correctly. And behind the super wood to hold it, we have wooden battens, which is placed horizontal, and under there is 12 millimeters of ventilation. And then behind that there's a 9 millimeter windstopper plate from Sembrid, which protect our wood construction and our gramitherm isolation from fire, wind, and rain. And our load-bearing element consists of construction wood, and then of course the isolation is gramitherm, which consists of grass, and the lambda value here is 0.46. And then behind that we have our vapor barrier from DAFA, and it must ensure that no moisture from inside the house is penetrating into the structure. And on the inside we have 2 layers of drywall, which make our construction comply with fire requirements that is needed when we have this grass insulation. Yeah, and then we have some calculations on the U value. And in order to implement this gramitherm in our external wall construction, we have calculated the U value for the entire wall. And most of the calculation is from our main project, where we're using a different kind of insulating material. But here we've used the gramitherm, and we had to make a few changes in the wall construction, which enabled us to meet the energy requirements from BR18. So the thickness of our insulation layer had to be increased from 240 millimeters to 295 millimeters, which also resulted in having to use a thicker post in the wall. And all these changes after we made them, we could calculate the final U value of our wall, and it ended up being at 0.14, which meets the BR18 requirements, which is at 0.30. And you always look to meet half of this, so 0.15, and we have 0.14. So it should meet the energy requirements that are needed. Yeah. And then we have looked a bit into fire analysis, because one of our main concerns with using a grametherm is the low fire resistance of the material. Grametherm is categorized as an EU class E material, and this tells us that the material easily catches on fire. So therefore we had to ensure that our materials on both sides of the insulation is good at resisting fire. And on the outside of the insulation, it is protected by this windstopper from Sembrit, and as you can see on the PowerPoint, it has really good fire resisting quality. And on the inside we have these two layers of drywall, which also gives us a good protection from fire. So these two materials we had to use on the both sides of the material to ensure that it would not easily catch on fire and ruin the building. Yeah, and then we've made a price comparison between a normal wall with bricks and mineral wool, and a more sustainable one with wood and grametherm. And if we look at the prices, the normal wall is at 1,700, where the grametherm wall is at 4,000. So there's really a big price difference between the two, and that is something you have to take into consideration when building with these more sustainable materials, because right now the demand of sustainable materials is lower than it is for bricks, for example. And that is something you have to take into consideration if you want to leave less of a carbon footprint.